Right, graduates, now that you've watched the first video and hopefully taken down all the notes neatly in your workbook, these are the examples that I've chosen to do in your workbook, and then there'll be an exercise for you to do as classwork. So, examples, first thing says simplify the following. Now don't forget to hit pause and write down the questions and answers when you feel like it's a good moment. So simplify the following. First question, square root of 25. So in my head I said to myself, what multiplied by itself gives me 25. Now you could use your calculator, but hopefully we start to know our cube roots and our square roots of small numbers. So I know that 5 times 5 gives me 25. So the square root of 25 is 5. Right, next one. What multiplied by itself would give me x to the power of 8? So if I had 8 x's and I had to divide them up into 2 equal groups, I would have x multiplied by itself 4 times in each group. Because when you multiply powers of the same base, you would add those two exponents together. So I'm basically dividing an exponent of 8 into 2 separate groups. Okay, so can we make it a little bit more difficult where we have 2 different factors? So I'm square rooting x to the power of 10. Now, of course, you don't have to write this. I'm just, if you're answering this in a test, you don't actually have to write that line. I'm just showing you that I'm square rooting both parts. So I'm square rooting x to the power of 10. I have x multiplied by itself 10 times. If I put into 2 equal parts, there will be x to the power of 5, and 6y's into 2 equal parts would be y cubed. Right, on to the next one. This means that I'm going to square root 16, and I'm going to square root a to the power of 16. Now, of course, again, I wouldn't write that down in a test, but that's what my brain is thinking. So I say to myself, what number times itself gives me 16? 4 times itself gives me 16. Then I say, right, I have a multiplied by itself 16 times. If I'm dividing that into 2 equal parts, well, if I have a multiplied by it 16 times, I will have a multiplied by itself 8 times in each of those. And so that's a to the power of 8. Now this is a really good example to show you that numbers and exponents behave very differently. Because when I'm square rooting 16, I get 4. Because what number times itself gives me 16. But when I'm square rooting a to the power of 16, notice I don't get a to the 4. Because you don't square root the exponent. You say to yourself, if I have a multiplied by itself 16 times, how many would I have if I've divided into 2 equal parts? So numbers and exponents behave very differently. Right, on to cube root examples. What is the cube root of 8? Well, what times itself gives me 8? I could use my calculator, but that's 2. Then if I have 9x to the power of 9, so x multiplied by itself 9 times, but I'm dividing into 3 equal parts, I will have 3 x's in each part. Okay, on to the next one. I can make lots and lots of factors in this question, but basically what this means is I'm cube rooting 64, I'm cube rooting the a to the power of 12, and the b to the power of 6, and the z to the power of 18. So I just cube root each of them. So what times itself gives me 64? If you're not sure, you could check on your calculator, but I know the answer is 4. Then if I have a multiplied by itself 12 times, but I'm dividing into 3 equal parts, that's a to the power of 4. B multiplied by itself 6 times, but divided into 3 parts, would be 2 in each part. And 18 divided into 3 equal parts would be 6. And so I basically land up dividing my exponents by what root I'm doing. Okay, let's do a couple more interesting ones. Can I do this? Can I do, oh gosh, I'm square rooting 16x to the power of 12, and I'm square rooting 9x to the power of 12. Is that allowed? Now that looks like exactly what you've done there in F, because in F I cube rooted each of the parts individually. So why am I not allowed to do this? The difference here is, do you notice that this in F is all one term? And when something is one term, you under the root sign, you are allowed to root each factor individually, but only when it is one term. So when there's one term under the root sign, you're allowed to root each factor individually. Okay, but the moment there are 2 terms, you can't do this. So because there's 2 terms, you cannot root each term. And this is a mistake that children will make from now until matric. So it's really important. You cannot root each term. So I'm going to say no. What you first need to do is to see, can you add those terms together? If you can't add them together, then you can't do the question. So can I add them first? So I must first try and add them. They don't necessarily have to be able to be added. So I must try and add them. Are these like terms? Well, they're both x to the power of 12 terms, so they have the same x's and the same exponent, so they are like terms. Now remember, when you add things, I have 16 apples and then I bought 9 apples, means I have 25 apples. Remember, you don't change that exponent. We're adding like terms. We're not multiplying anything, so my exponent doesn't change. And now, because there's one term under the root sign, you can square root each of those factors individually. So you can say the square root of 25 is 5, and if I have x multiplied by itself 12 times, there will be 6 in each group. Okay, so a couple of more interesting ones. What happens if I'm square rooting? What happens if I'm square rooting and there's a fraction? Well, it's not a problem as long as there is one term. So notice there is one term here. Now, as long as there's one term, you can square root everything individually. Now, notice I wrote a 3 there when I meant to write a 4. So let me go change it quickly. So what is the square root of 9? The square root of 9 is 3. Now, why did I have to change that 3 to a 4? Why did I make a typo? I knew I'd made a typo because if you have x multiplied by itself 3 times, can I divide that into 2 equal groups? And the answer is no. So when we are in grade 11, we'll do examples like that, where you can't divide them into 2 equal groups, and then what do? So for now, we'll always give you even exponents for square roots, because if it's x to the power of 4, I can divide them into 2 equal groups. And then y to the power of 10 would be y to the power of 5. Right, let's have a look at I and k. If I have a look at I, this one's interesting because can I simplify under the root first? Now, I don't have to simplify under the root first, except I kind of think that I need to here, because do you see that there's 7 a's? Now, I can't divide 7 a's into 2 equal groups. So if I can, I'm first going to simplify under the root sign, just because it might make my life a little bit more simpler. So first simplify under the root. So what is 36 divided by 9? So I'm going to ignore the root for now. 36 divided by 9 is 4. If I have 7 a's at the top and 3 at the bottom, I'm left with 4 at the top. And now that's a very easy root to do, because the square root of 4 is 2, and 4 a's would give me 2 and 2 in each group. Okay, on to the next one, the last one. Cube root of negative 8 over x to the power of 6. Now, I chose this example because can you cube root a negative? Can I say what times itself gives me negative 8? Now, I'm chosen to put that negative with the 8, but it doesn't really matter who that negative belongs to. I just thought it would be easier. So, I know that 2 times 2 times 2 would give me 8. So would you agree that negative times negative times negative would give me the negative? Because a negative times a negative make a positive, and then times a negative would give me back to my negative. So the cube root of negative 8 would be negative 2, and if I have x multiplied by itself 6 times, there would be x squared in each group. So hopefully you've copied down all of those, pushed pause when you needed to, and written down what notes you think will help yourself. What you need to do now as classwork is to try exercise 10. And then I'll make a quick video in order for you to mark exercise 10. So you can get going on exercise 10 now.